In this video, we're going to be discussing dividing radicals. So in a previous video, we discussed how to add, subtract, and multiply radicals. And for this video, we're going to talk about dividing, which is very similar but has a couple little extra steps. So for a simple dividing radicals problem, okay, if both the numerator and denominator of your fraction are radicals, you're going to just follow the same sort of rules you would follow for multiplying. You're going to divide the outside by the outside, inside by the inside, and simplify whatever radical you have left over. So for example, I've got this. 12 times the square root of 160 over 2 times the square root of 5. All right, so we're just going to follow our rules of doing outside divided by outside, inside divided by inside. So that's 12 divided by 2. And then the nice thing with square roots is I can do something like this, or the square root of 160 over the square root of 5, I can put them both under one radical and have the square root of 160 divided by 5. If I work this out a little farther, okay, 12 divided by 2 is 6, and 160 divided by 5 is 32. So this becomes 6 times the square root of 32. Now 32 is not a perfect square, so I have to simplify that radical. And 32, the biggest perfect square that goes into 32 is 16, and its factor pair is 2. So 16 goes in its own radical, 2 goes in its own radical. So now I want to do the square root of my perfect square. Square root of 16 is 4. So I've got 6 times 4 times the square root of 2. 6 times 4 is 24. So my answer ends up being 24 times the square root of 2. So I just divided outside by outside, inside by inside, and simplified our radical. Now, sometimes we're going to have a more complicated problem with dividing. Now we have to do what's called rationalizing the denominator. So basically, when you're done simplifying, you should never have a radical left in the denominator. Okay, radicals in the denominator are the truly improper, unacceptable fractions. So we got to do something about that. And the process of removing any leftover radicals from the denominator is called rationalizing the denominator. So let's look at how we're going to do that. So we've got two possible options. If it's a monomial denominator, okay, monomial meaning there's only one number there. So like something would be like 3 over the square root of 6, say. Okay, 3 over the square root of 6. The denominator is a monomial because there's only one term down there. To solve this one, you simply multiply the top and bottom by your radical. If you have a binomial denominator, and a binomial denominator would be like if I had something like 4 over 1 plus the square root of 2. Okay, the bottom is the denominator is a binomial because it has two terms. If it's a binomial denominator, we're going to have to be a little more complex here. We have to multiply the top and bottom by the conjugate of the denominator. All right, so what's a conjugate? Well, a conjugate's really easy. If you've got a complex number, like say 2 plus the square root of 5, then the conjugate is simply the same expression but with a different sign. All right, so 2 plus the square root of 5 and 2 minus the square root of 5 are conjugates. And the nice thing about conjugates is if you multiply them together, your final answer will not have a radical in it. So we're going to look at some examples of how to do both problems with a monomial and binomial denominator. So let's look at our first example for rationalizing the denominator. So this says to simplify 3 over 2 square root of 5. So now even though there are two numbers in the bottom here, because they're being multiplied together, these are just one term. So this is a monomial denominator. So to rationalize a monomial denominator, all we need to do is multiply both the top and the bottom by our radical. So it's going to look like this. I'm going to take my my expression here, 3 over 2 square root of 5, and multiply top and bottom by square root of 5. So if I work this out, on top, 3 times square root of 5 is just 3 square root of 5, and 2 square root of 5 times square root of 5, if I think about this, square root of 5 times square root of 5 is just 5. Because if you think about it, what does that mean? Well, if I do square root of 5 times square root of 5, Okay, if we think about when we did simplifying radicals, or when we do multiplying radicals, square root of 5 times square root of 5 is square root of 25. Because we multiply the insides, 5 times 5, and the square root of 25 is just 5. So when you multiply a square root by itself, you just cancel out the square roots. So now I've got 2 times 5 on the bottom, and 2 times 5 is just 10. So I get 3 times the square root of 5 over 10. That can't simplify anymore, so that's our answer. So to do this, all we do, multiply top and bottom by our radical. Now example 3, I've got a monomial, or a binomial denominator, because I have two terms. I have 6 minus square root of 5. So I need to multiply top and bottom by the conjugate. So the conjugate of 6 minus the square root of 5 is simply 6 plus the square root of 5. So I'm going to multiply top and bottom by 6 plus the square root of 5. So if I work that out, I've got to do some distributing. 2 times 6, 2 times square root of 5. 6 times 6, 6 times square root of 5. Negative 5 times square root of 6, 6 times square root of 5. I'm sorry, whoops, back that one up. Square root of 5 times square root of 5. So I've got to do some distributing on the top and the bottom. So if I work all that out, 2 times 6 is 12. 2 times square root of 5 is 2 square root of 5. 6 times 6, 36. 6 times square, or negative 5 times negative square root of 5 times 6 is negative 6 square root of 5. 6 times square root of 5 is plus 6 square root of 5. And negative square root of 5 times positive square root of 5 is negative 5. Now, on the bottom, I've got some simplifying I can do. Negative 6 square root of 5 plus 6 square root of 5, since one is positive and one is negative and they're the same number, those two cancel each other out. And then 36 minus 5 is 31. That should say 31, not just 1. Don't know why that happened. Okay, well, not going to do it that way. Should just go like this, 31. All right, so I've got 12 plus 2 square root of 5 all over 31. So if I look at this, I don't think I can do any sort of simplifying any farther. So that is just my answer. I've got my square root out of my radical, so I'm all good to go. And I can't simplify it any further, so that's my answer. 12 plus 2 square root of 5 over 31. All right, so I'm going to leave you with a try it problem. I want you to simplify 4 over 4 plus the square root of 2.